Welcome to Maths is Easy. So today we are doing Understanding Quadrilaterals, Class 8, Exploring Mathematics, Exercise 11.1. Hashtag 3 is the serial number of this video. So question number 7 says, find the measures of each interior angles of a regular pentagon, hexagon and decagon. What we have to do here, we have to find out the interior angles of a regular pentagon. How we will do it? Let's check it out. So how we will do it? We will be starting with solution for what? First, pentagon, of course. So the measure of each interior angle of a regular pentagon, we would write the measure of each interior. I am abbreviating interior as int dot angle as this of a regular pentagon. How we will do it? N means number of sides. So pentagon has 5 sides, of course. N minus 2 into 180 degree divided by n, number of sides. So n minus 2 would be 5 minus 2 into 180 degree divided by what? 5. So it would be like 3 into 180 degree. So 5, 5 3s are 15, 5 6 are 30. So 3 6 are 18, 108 degree. So the sum of the measure of each interior angle of a regular pentagon, the measure of each interior angle of a regular pentagon would be 108 degree. This is our answer. Let's move further. So here the interior, we have to find out now the interior angle of a regular hexagon. For hexagon, same thing, same formula will be used. N minus 2 into 180 degree. N stands for number of sides divided by n. So for hexagon, n minus 2 equal to 6 minus 2 into 180 degree by 6. So 4 into 180 degree by 6. 6 3s are 18, zeros are. So it would be like 120 degree. So hexagon interior angles measure, interior angle measure, each interior angle measure equal to 120 degree. One thing here, so if you guys want to see the solution of earlier chapters of this exploring mathematics, you can go by the description of this video where I have solved many chapters of previous term, that is first term, and second term also. The chapters name are rational numbers, exponents, powers, and compound interest, and understanding quadrilateral previous exercises, of course. And if you want to see the solution of mathematics success of Goyal brothers Prakashan, many chapters have been solved. I'll give the I'll give all the links of description in the description of this video of those chapters. Moreover, I have solved 7 class chapters of mathematics success of Goyal brothers. So do check it out. Now come to the decagon. So for decagon, the measure of each interior angle of decagon would be what? Same formula will be used. N minus 2 into 180 degree by n. So decagon has how many sides? Of course, 10 sides. 180 degree divided by 10. That is 8 into 180 degree by 10. So it would be like 8 8 is 64, 8 1s and what will be the answer? 144, 14, 144. So measure of each interior angle of a regular decagon would be what? 144 degrees. So it was all about question number what? 7. Let's move further. Question number 8. So question number is 8. So the question number 8 is find the measure of each exterior angle of a regular polygon having So here we have to find out measure of each exterior angle of a regular polygon having 8 sides. How we will do it? Question number 8. So for 8 sides, we will be writing what? For a regular polygon of n sides, for a regular polygon of n sides, we will write each exterior angle will be what? 360 degree by n, that is 360 degree by 8. So answer would be 8 for the 32, 8 5 the 40, 45. Each exterior angle of a regular polygon of 8 sides will be 45 degree, not 42, 45 degree. Let's move further. 8 sides. Now for another part, 9 sides. So we will be writing the same thing for a regular polygon of n sides. Each exterior angle would be 360 by n, means 360 degree by 9, 4 is 36, 40 degree. So measure of each exterior angle of a regular polygon of 9 sides would be 40 degree. Let's move further. Third part, 12 sides. 12 sides. Same thing will be followed for a regular polygon. For a regular polygon of n sides, each exterior angle would be 360 degree by n. Therefore, required angle, we will be writing therefore required angle forbid for the handwriting because I'm doing it very much fast because many more questions are also there. So it would be 30 degrees. So for a regular polygon of 12 sides, n sides here means 12 sides. So each exterior angle would be of 30 degree. So it was all about question number 8. Now let's move further. Question number, we have done question number 7, question number 8. Now question number 9. Find the number of sides of a regular polygon, each of whose exterior angle measures 45 degree. Just remember that this is HOTS question. So be careful while attempting the HOTS question. So for question number 9, we would be writing what? For question number 9, we would be writing number of sides of a regular polygon. We will be writing number for first 45 degree. We will be writing number of sides of a regular polygon. Number of sides of a regular polygon. We will be writing number of sides of a regular polygon. How much sides? How we will do it? Divide 360 degree with 45 degree. The angle we have been given, we will divide this angle with 360 degree. So it would be like what? 72 and 9, 5 nines and 5 sevens and 8. So it would be having 8 sides. It would be having 8 sides. I think this much questions are very much clear. Now, second part, if the angle is given as 30 degree, we will be writing for number of sides of a regular, for number of sides of a regular polygon, we will be dividing 360 with that number only. So it would be having 12 sides. Let's move further. Third part is how many side? what angle is given as 20 degree. So solution would be what? For number of sides, for a number of sides, for number of sides of a regular polygon, for a number of sides of a regular polygon, for a number of sides of a regular polygon. So we will divide 360 by 20. So 18 sides. We will be writing what? 18 sides. So it was all about question number what? Question number 9. Now come to the question number 10. Question number 10 is given as how many sides does a regular polygon have if each of its interior angle is 144 degree and 160 degree. So how we will do it? Just see. So we are doing question number what? Question number 10. First part 144 degree. So we will be starting the solution with let the regular polygon has n sides. Let the regular polygon has n sides. So then we will be writing n into 144 degree will be equal to what? 2n minus 4 into 90 degree. Now we will write 144 and equal to what? 180 and minus 360 degree. In our next part, and would be what? And would be equal to what? 360 upon 36, 10 sides. I hope in between calculation is clear to you. If not clear, I'm doing it here. 144 and minus 180 and will be minus 360. So it would be equal to what? 36 and minus 36 and minus 360. So and would be what? 360 by 36, which would be equal to 10 sides. Let's move further. Now 160 degree. Second part is given as 160 degree. So 160 degree solution, we will be writing let the regular polygon has n sides. Let the regular polygon has n sides. So it would be equal to n into 160 degree, which is given to us 2n minus 4. We will be writing 2n minus 4, 160 degree. 2n minus 4 into what? 90 degree. So it would become 160 and equal to what? 180 degree and minus 360 degree. So 160 and minus 180 and minus 360. Minus 160 minus 180 would be minus 20 and that is minus 360. Cancel and would be equal to 360 by 20. So it would be equal to 18 sides. It would be equal to 18 sides. Now come to the question number 11. So question number 11 is given as what? Question number 11 is given as, is it possible to have a regular polygon each of whose interior angles measures 145 degree? It is Hart's question. It is also a Hart's question. So we will be writing what? For question number 11, the answer would be since. Answer would be what? Since n must be a whole number. Since n must be a whole number, this equation has no integer solution. This equation has no integer solution. Therefore, it is not possible. Therefore, it is not possible to have a regular polygon. Therefore, it is not possible to have a regular polygon with each with each interior angle equal to 145. Equal to 145. What does it mean? It means that and must be. And means and means number of sides must be a whole number. This equation has no integer solution because it is having no integer solution means no integer is there. It is not possible to have a regular polygon with each interior angle equal of 145 degree, because for the number of sides would be what? Sides should be in the integers, mean 1, 2, 3. Sides shouldn't be 1.5, 2.5 or 7.3. So for 145 degree, it is not possible to have a regular polygon. Now, I think it is quite clear. If any type of doubt is there, please feel free to ask your doubt by commenting in the comment box. Now, question number 12. Question number 12 says what? Is it possible to have a regular polygon with measure of each exterior angle as 25 degree? So for this, answer would be what? For question number 12, answer would be what? No, it is not possible. No, it is. No, it is not possible. No, it is not possible to have a regular polygon. To have a regular polygon whose each exterior angle measures 25 degree measures 25 degrees because the number the number of sides calculated by dividing 360 degree by 25 would not be a whole number. Would not be a whole number. So, which is a requirement. We will be writing which is a requirement. For a polygon to be regular. So if a regular polygon is there, number of sides should be in integer. But if we divide 360 by 25, it would be not a whole number. So it is not possible to have a regular polygon with that. Now let's move further. Question number 12. It is HOTS questions again. So is it possible to have a regular polygon with measure of each exterior angle? Question number 13. Whenever Rahul and Manjeet study in the same class, they usually play together and share their toys and things with each other. They all have same cardboard cutouts as shown below. So here, Vinay's cardboard cutouts are there. Rahul's cardboard cutouts are there. And Manjeet there. So we can say these are Vinay cutouts. These are Rahul cutouts and these are Manjeet cutouts. So first question would be, we will be facing what? Write the names of shapes each boy has. So we will be writing the names of shapes, and this is value-based question. So first write the names of each boy has. So answer would be Vinay cutout. First, heptagon. Second cutout is pentagon. And third cutout is hexagon. So it was Vinay. Now B part, Rahul cutout, nonagon means 9 sides and triangle means 3 sides. C, Manjeet cutout, octagon, and quadrilateral means 4 sides. So this was A part. Now come to the B part. So B part is what? So B part is given as find the sum of the interior angles of each shape. So here For each shape, we have to find out the sum of interior angles. So of course, for first heptagon, sum of interior angles would be what? For heptagon, A part, heptagon sum of interior angles, we will be writing sum of interior angles of heptagon. First was heptagon, so sum of interior angles of heptagon would be 2n minus 4 into 90 degree. That is, so heptagon having 7 sides, 2 into 7 into 90 degree, 2 into 7 minus 4 into 90 degree. We will be writing 2n means 2 into 7 minus 4 into 90 degree. So 14 minus 4 into 90 degree, that is 10 into 90 degree, that is 900 degree. So sum of interior angles of heptagon would be 900 degree. Let's move further. Second was what? Pentagon. So sum of interior angles of pentagon would be second, sum of interior angles of a pentagon. Sum of interior angles of a pentagon, same formula will be applied. That is 2n minus 4 into 90 degree. So pentagon having 5 sides, 2 into 5 minus 4 into 90 degree. So 10 minus 4 into 90 degree, 6 into 90 degree means 540 degree. Now come to the third part. Third part is given as what? Third part is given as hexagon. Third part is given as hexagon. So third part is given as hexagon. So sum of interior angles of hexagons, same formula will be applied. 2n minus 4, 2n minus 4, 2n minus 4 into 90 degree. So hexagon being having 6 sides, 2 into 6 minus 4 into 90 degree. So it would be like 12 minus 4 into 90 degree. That is 8 into 90 degree. It would be equal to 720 degree. Sum of interior angles of hexagon would be 720 degree. Let's move further. For nonagon, sum of interior angles would be fourth part. Same formula will be applied. 2n minus 4 into 90 degree. So nonagon being having 9 sides minus 4 into 90 degree. So 18 minus 4 into 90 degree. That is 14 into 90 degree means 1260 degree. So fifth part is given as what? Fifth triangle, for triangle fifth. So fifth is given as triangle. So for triangle, same formula will be applied. 2n minus 4 into 90 degree. So for this, 2 into 3 minus 4 into 90 degree, that is 6 minus 4 into 90 degree, that is 2 into 90 degree, that is 180 degree. Now sixth is given as what? Octagon. Same formula, octagon being having 8 sides, 2 into 8 minus 4 into 90 degree, that is 16 minus 4 into 90 degree, that is 12 into 90 degree, that is 1080 degree. Seventh is given as what? Now seventh is given as quadrilateral. Same formula will be applied. Same formula will be applied. So 2 and minus 4 into 90 degree, quadrilateral being having 4 sides, 2 into 4 minus 4 into 90 degree. So 8 minus 4 into 90 degree, 4 into 90 degree, that is 360 degree. Now next question. How many diagonals does each shape have? For calculating the diagonal, we'll be writing number of diagonals. For heptagon, number of diagonals first. For heptagon, number of diagonals n minus 3 by 2. That is 7. 7 minus 3 by 2 for heptagon. I'm doing this 7 into 4 by 2 to 14 diagonals. So heptagon having 14 diagonals. Next, for octagon, second, for pentagon, second is pentagon. For pentagon, number of diagonals would be n minus 3 by 2. So pentagon having 5 sides, 5 minus 3 by 2. So 5 into 2 by 2. So pentagon has 5 diagonals. Pentagon has 5 diagonals. For third is hexagon. Hexagon number of diagonals would be calculated by n minus 3 by 2. That is 6. 6 minus 3 by 2. That is 6 into 3 by 2. 2 3s are 6. This is not, it will not get cancelled. 6 into 3. So 3 3s are 9 diagonals. So hexagon having 9 diagonals. Fourth, nonagon. For fourth nonagon, we will be writing nonagon being having 9 sides. 9 minus 3 by 2. That is 9 into 6 by 2. 2 3s are 6. 27 diagonals. 27 diagonals किसके लिए? Non-agon. For non-agon. For non-agon. Fifth, triangle. Number of diagonals in triangle. n minus 3 by 2. That is 3. 3 minus 3 by 2. That is 0 by 2. That is 0. So triangle has no diagonals or 0 diagonals. Sixth, octagon. Number of diagonals, same formula will be applied. n minus 3 by 2, that is 8. 8 minus 3 by 2, that is 8 into 8 minus 3 means 5 by 2. 4 is 20 diagonals. 20 diagonals. Now for next, seventh quadrilateral. For seventh quadrilateral, 4. 4 minus 3 by 2, that is 4 into 1 by 2. 2 diagonals. So a quadrilateral has 2 diagonals. Now it was all about C part. Now D part, which is the last part. So last part would be what? By sharing their toys with each other, what qualities do these boys show? So by sharing their toys, we will be writing by sharing their toys with each other, the boys show what? Generosity. I'm doing it right. Generosity. GENEROSITY. Cooperation. COOPERATION. Empathy. With their peers. So it was all about exercise 11.1, understanding quadrilaterals. So if you guys like my videos or if it is somewhere helpful to you, subscribe to my channel, hit the like button and share the videos as much as possible. So your one like, one share make a big difference. Thank you so much.